The next module that I want to show you is the TMA or TRACON. So the en route module is used to model and simulate the traffic while en route, whereas the TMA module will allow you to simulate the aircraft from when it's handed over from the en route phase to when it touches down at the destination airport, or from when departing from its origin until it reaches the en route phase of the flight. So why using the TMA module? Well, the main purpose is to assess the traffic complexity and optimize the TMA airspace structure. With the TMA module, you are able to define and simulate all the departure procedures, so essentially the seats, the approach procedures, stars, approach legs, and with all its relevant characteristics, such as the sequencing, vectoring areas, being that point merge or the classic trombone, the holding stack, and so on. So as per the en route module, the TMA can be linked to the en route, flow management, and also airside modules. For the departure procedures, well, the departure procedures are defined considering the static restrictions, such as the speed range, altitude range, course, and so on, but can also be linked to the airside path. So, for example, to consider different strategies when allocating aircraft to different runway entries and to optimize the departure sequence. Like I mentioned, it's possible to define very specific and complex conditions to mimic the actual operations that take place in the real world, making the AirTOP module as accurate as needed. For example, adopting a seat allocation strategy depending on the current demand, on the traffic mix, on the ground operations, such as the de-icing, towing, literally you name it. Anything that is simulated in the model, anything that is reproduced in the model can be used to then create specific complex conditions to reproduce what happens in the real world. In this animation, you can see how aircraft are simulated while taking off from a single runway, following the seat legs with their course, altitude, speed limitations, while maintaining the required separation between them. You can also notice that the aircraft trajectories can be color-coded to show the altitude evolution while taking off from the airport. So in this case, red is when they're taking off, so lower altitudes to then become yellow, then green, and bluish, and so on. The same goes for the arrival procedures. In fact, the arrival procedures are an essential part of the TMA airspace, as it will connect the en route airspace with the airports, hence determining how efficiently the airport can operate, managing the demand, absorbing the delay when necessary, and properly optimizing the sequence of arrivals. Again, it goes without saying that the model will be simulating both arrivals and departures at the same time, so hence providing an accurate view on the interactions between the departures and arrivals, and how the airport can operate, and essentially how the airspace can cope with the demand in order to optimize and hand over the traffic from the en route to the airport. In this other animation, you can recognize the vectoring areas used to fine-tune the separation between arrivals and make sure that the sequence is handed over to the airport controller as requested, with the requested separation. There are different ways to simulate how approach controllers can sequence the aircraft while approaching the airport. So then the resulting effect of these strategies can be measured and essentially compared to validate the model, hence validating the different TMA designs. All of these within AirTOP. As I mentioned before, for the en route module, all of the data produced during the simulation will be available and can then be used to produce plots, populate spreadsheets, and also be exported as table files, for instance, CSV files. Can also be exported to SQL databases or simply as image to be included in reports. Another powerful feature of AirTOP is to allow to run multiple runs in sequence. For example, adding a random variation between the different simulations to increase the confidence of the results, as opposed to only having one simulation result.